We're back.
Yeah, and we're on air now with our first session.
Come
Yes.
on.
So I had the chance to go to South by Southwest last year. And at South by Southwest, I got to see Amber Case speak. And she is just truly a remarkable person in so many ways. And I think it was very important for me to uh, ask her to kick off our event. And thank you again to SDI for helping us make this happen. Uh,
Pleasure.
it's unfortunate though. She's in Paris today. If you're following her on Instagram, and under the weather, so she can't actually be here. So we actually have to start with a redundant system. Uh, but we're going to go ahead and we're going to push through this. So what you're about to see is me talking to Amber and Amber presenting her session on "We're All Cyborgs Now." So Kirsty, when you're ready, if you want to go ahead and share your screen and remember to put the focus on you. And then Emma, you and I are going to just mute and dark out.
We are.
So while Kirsty's getting it ready, getting that ready, you can follow Amber on Twitter at Case Organic, and that's CASE Organic, Case Organic at Case Organic. You can wish her well. And she's struggling, and we're going to go ahead and start.
Okay.
Take it away, Kirsty.
Hi everyone, my name is Amber Case, and
Hey Amber, how are you?
I'm doing well. How are you?
I'm really excited to be with you today. This is an inaugural event that we're trying to do semi-annually for technology professionals, people who work in IT around the globe. And when I had a chance to meet you at Cyborg Camp in person after seeing you on TED and seeing you at South by Southwest, I thought I would just be so honored if you could be involved in this. So if you could introduce yourself and then maybe share your thoughts on kind of the future of location and interface.
Sure. So my name is Amber Case. I live in Portland, Oregon. I started a company called Geoloqi, which is a company trying to push forward the entire industry of location-based solutions. It was just acquired by Esri a month ago. And I'm also known for studying the future of humans and technology. There's a field called cyborg anthropology, which allows you to kind of step back and objectively see how technology is affecting us over time. So that's kind of what I do, and I'm here today to talk about location and the future of the interface. So with that, I will begin.
Nice.
So the first thing I usually tell people is that they're all cyborgs. And it's a silly thing to say because when people think of cyborgs, they usually think of Terminator or they think of RoboCop. And in reality, the word for cyborg came from the 1960 paper on space travel, in which exogenous components were added to people in order to allow them to adapt to new ambient environments. And that giant mouthful really just means that if you are a person and you put on a spacesuit, you can work very well in inhospitable environments. And humans are very good at adding all these external prosthetic devices onto themselves in order to become new things. So if you think about it, every time you interact with a piece of technology through the interface of your eyes, or through the interface of your hands, or through your brain, you're actually symbiotically interacting with that technology. You're actually being very cyborgian, even though those aren't implanted into your skull. You're having this symbiotic relationship with a computer, and it's having a symbiotic relationship with you. So if you think about it, if you go back in time, 3,000, 4,000 years, when you look at some of the earliest tools, they're all extensions of the physical self. So if you look at a hammer, for instance, that hammer, its form, its function is really an extension of the fist in order to hit things very hard. And the shape and form of it has not changed very much over time. The form and function are still almost identical. The process of building it has changed quite a bit, but in reality, it's very, very similar. But if you look at a phone, for instance, that nothing about its form suggests its function. It has become smaller and smaller over time. It's kind of become this disappearing thing. So if you look at the UNIVAC versus the iPhone, nothing about this machine says what it actually does. And that's because it's an extension of the mental self. And cave painting and cave writing and scrolls and things like that were also our early extensions of mental selves. So that's been kind of a strange topic for me. If you look at the future of technology, it seems to be shrinking more and more. Now our devices are larger on the inside than they are on the outside. We live in worlds that are maybe 11, 13 inches and 15 inches wide and 500 miles deep. I kind of think of them as Mary Poppins bags. You can put any amount of information in them, and they don't get any heavier. I kind of had this running joke about, when someone is hoarding things when you walk into their house and they have newspapers stacked up everywhere and thousands of cats. But in reality, if you look at somebody on the web, they're also doing very similar things. They're reading tons and tons of news articles, saving them to read later, even though they won't because they think they're valuable. And they, a lot of people look at pictures of cats. So in reality, a lot of us are cat and news hoarders. None of this information takes up any space, so we actually don't experience that as a hoarding behavior because it's so invisible and lightweight, and it walks around with us in our pockets. So the funny thing was, in the 80s and 90s, we thought that people would go into these little virtual reality bubbles all the time, and that's where we would go to. But in reality, it doesn't take that much for a human to think that they're in a different reality. And the example is very simple. If you read a fictional book, oftentimes you can become more enamored by the characters in a work of fiction than you even know your neighbors next door. And you only get a two-dimensional interface of text in order to have that hallucination of value, right? So on Facebook, your brain technically extends to whatever vessel it's in, right? So if you step into a car, your perception will extend out to the edges of that vehicle. If you develop an account on Facebook, your perception also will extend out to the edges of your profile. And you kind of have this little neural network or this kind of system of reflexes and attachments so that when somebody likes one of your posts or pays attention to you online, you get a miniature dopamine hit. It's kind of the equivalent of a chimpanzee picking a gnat out of another chimpanzee's back. It's this grooming behavior. And so we only need 2 dimensions, and it only needs to be on a small interface for us to feel very similar to what we feel like in everyday reality with people around us. So there's a number of problems that happen with this. The biggest problem that a lot of people encounter is that, especially with all the data on the web, you get a lot of information piled on top of each other. So people's email accounts, I think of everyone as a modern day paleontologist, and the excavation site is their email account. And every time they try and go find something, they have to remember the search term, they have to dig it up, and they have the search tools, and yet more and more layers of silt and dust keep piling on top of their email accounts, and it never stops. So there's this whole very fast excavation site that's being done. And some people are more efficient paleontologists, and some people aren't, and they just let everything get covered and don't dig it up. The other issue is social punctuation. It's when you are in one particular time and space environment, like sitting down in a restaurant, and then somebody texts you or talks to you out of their own environment, and one person's reality is interrupting your reality. And so there's this kind of social punctuation that happens in that moment, where you are no longer just in one reality, you're in multiple realities. And you can also call that simultaneous time, or the idea of having information jet lag, where you're in different time zones and realities all over the place. So I'm going to talk a little bit about some history, because especially in a reality where we don't look very far back in time, because we're so very attached to the new and what's going on, it's really important to look at history and look at some people's ways of dealing with some of these problems. So I present to you this person named Steve Mann. He was a very interesting kid. When he was around 10, was walking down the street past a television repair shop. And he really wanted to work there, and he walked in and he said, "Can I work at your television repair shop?" And the television repair person said, "No, you absolutely cannot, you're way too young." And he kept going back day after day, and eventually the TV repair guy got mad and said, "Okay, only if you can solve this particular problem," and gave him a really obnoxious problem that he hadn't been able to solve himself. Steve Mann figured it out quite rapidly, and the TV repairman said, "Why the heck do you really want to work here?" And Steve Mann said, well, my father's in the textile business, and I want to make a computer, a television screen that's small enough to fit inside my eye so that I can have one part, this kind of augmented reality, and the other part of my world, just a plain vanilla world. And the TV repairman thought that was absolutely ridiculous, but this guy was smart and he ended up hiring him. So he worked repairing these televisions when he was little. By the time he got to college at MIT, he had made an 80-pound assembly of basically cybernetic equipment. You can see in this image, he has a modified bicycle helmet with antenna sticking out of his head. And the reason for that is that he hacked onto the local network at MIT, up onto the top of the building, put a little transmitter up there so that he could get a local area network signal so that he could get the equivalent of Wi-Fi for his 80-pound wearable computer. And he, in order to get a signal, would coat his hair with metallic gel in order to do that. During this time, he met his wife, and their first date consisted of them both wearing cameras on their head and both viewing the date out of the perception of each other's own eyes. So he would see the date from her perspective, and she would see the date from his perspective. It took him about a year at MIT to make friends that were also willing to wear this wearable heads-up display and giant amount of equipment around their waist. Also, it was nice because he was in Cambridge, and it was very easy for him to just wear this very heavy equipment that was warm, and he didn't have to wear extra coats and lectures. So that was one useful offshoot of wearing that much technology. But he had really big issues with seeing other people's images. He really didn't like the idea of seeing other people's advertisements. So he made, with James Fung, who's now working at NVIDIA, he made a way to cancel out reality and replace it with his own. So this is an example of him taking reality in one eye, processing it in a loop around the back of his head, and then putting it into his other eye with, basically canceling out a rectangle of an ad and putting text messages on top of it. And so this is a message from his wife that says, "Hey Steve, you've gone too far, turn left on Bay Street." And so that's one example. And he called this diminished reality, where you want to diminish parts of reality instead of augment reality. Here's an example of him canceling out a L'Oreal ad with his heads-up display and then reading a paper that he wrote. He also likes to edit Wikipedia while he walks down the street. He is a pretty frequent Wikipedia editor, and you can tell that he will edit Wikipedia when he's stopped at a stoplight, waiting to go across the street, and other things like that. So all of this wasted time that was formerly not really used is now used for him, because his idea is that you shouldn't have to sit and lean over a computer in order to do something. The computer should conform to you and allow you to be more human. So when you're walking through a park and you suddenly have a great idea while you're writing your thesis, you should be able to type it down right then and there without having to go back to a small office and sit there over a blank piece of paper where there's no inspiration. So he also did this thing called collaborative reality, where somebody else could view through his heads-up display what he was seeing. In this case, his wife would watch what he was looking at in the grocery store, and if she didn't like a brand, she would cancel it out, and you'd never see the brand again. So it was a very easy way to decide when you walk in the grocery store. You just see the objects that you want. It's very easy. Here's an example of his form of location-based notification was being able to program in something like Star Market. And actually, this is his wife, Betty, programming in every time Steve sees Star Market, tell him to remember to pick up the 2% milk. And then once he's done, then he can dismiss that notification.
Right.
This is an example of him recording everybody that he's seen with their own unique identification number and the interactions he's had with them. So in this case, this is cashier 623. He's purchased two DL123 batteries, probably for his heads-up display system. They're pretty used to him in these stores by this point in time. But also it's very useful. One of his students at Starner, who's now working on the Google Glass project, would use this to easily set up event notifications and reminders, also store the age of kids, the kids of people who he talked to, so he could be like, "How is your kid doing? He's now 7, right?" And the guy would be like, "Yes, he's doing just fine." This is another example of it actually was all of the information on top of reality came in at a 90-degree angle, so you can actually see him reading a message from his wife. She says, "Steve, you know, this is the teller to your right was the one before blah 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 about this certain thing that you need to remember." So he said, "Oh, thank you very much."
Amazing.
So he also came up with this concept. He was kind of a very artistic kind of political type, very amusing installations where he used himself as the artistic piece who would walk around. So he came up with the idea of surveillance instead of surveillance, and it's to view from below instead of surveillance, which is to view from above. So as you can see in this image, surveillance camera up in the ceiling, he's the surveillance camera viewing from below, and this is a project called Maybe Cam, and it's a maybe camera. It may or may not be recording, and it may or may not have a camera in it. You would walk into these stores and you'd be like, I'm recording for my own personal safety, versus, you know, those cameras in the store that are recording for your personal safety. And there are a lot of very awkward videos of him testing this out and videotaping in the store, and people absolutely freaking out. But he said in the future, everyone will have very small electronics with the ability to record, and everyone will be able to basically police from many different viewpoints. So during a protest, you'll get 100 people's opinions instead of the news opinion, and if some sort of personal rights issue is happening, people will be able to record it. And of course, all of that happened. He also made a system called Geoloqi, which would allow you to install that sort of recording device on a very old phone. And there are a bunch of different vloggers all over the world that record in that form over time. Over time, he didn't have to wear 80 pounds of computer equipment anymore. He always told people, he said, look, it's going to get lighter and lighter, and it's not going to be a very big deal anymore. And as you can see in 1998, he looks kind of cool. Everything's embedded into his sunglasses. And he's got this little tiny device, if you look at the bottom right, that allows him to input while he's walking around. And I'll talk a little bit about that later. This is him in present day. He's got this very thin pair of glasses. He has a laser input directly onto his iris, and he can just really just interact with people normally. This is one of his daughters. He's now working on a bunch of different cool musical instruments using different forms of matter. And he is pretty much, you know, settled with his heads-up display, which I think at any given moment he wears about $500,000 worth of computing equipment when he walks around. This is one of the early prototypes. Usually when I talk about this in real life, I have one of these early prototypes that, you know, has been made by this guy up at Microsoft to let me borrow, and I usually wear it and pass it around and allow people to use it. But it's a very early MyView goggles that has been cut in half. And the MyView goggle, there have been so many people that have been trying to do augmented reality technology for just a very long time, but all of them have really failed. And there's been a number of reasons for it. I mean, one, there isn't really a market for one-eye wearable headset displays, because really it's been marketed for business executives on planes to be able to watch videos privately. Which I'm only guessing what those private videos would be that you don't want anyone else to watch them. There've been all these different companies that, you know, Microvision, which is out of business, MyView is out of business. You can barely get any of these heads-up displays anymore. There were a bunch of different wearable computing groups that were all over the United States. Those no longer exist. It's kind of gone away. So you know, these are some examples. You know, this is a NASA VR system from 1993, and you know, that's kind of the idea that it went away. So now I'm trying to look like what's going to happen in the future of this. Well, one of the other issues is that even if you make a great wearable heads-up display, you still have the problem of input. So what's the big problem with input? Well, it's how the heck do you know, now that we have these liquid crystal displays, how do you know what buttons you're pressing without having to look down? The whole point is to get you to move around and not have to look down or up at a screen and know what you're typing. And this is one of the earliest prototypes for the original computer mouse by Dan Engelbart. And that was not supposed to be a persistent device. It wasn't supposed to be the solution. People weren't supposed to use the mouse. It was supposed to be a temporary holdover before something better came along. And of course, something better came along only a few years ago with, you know, the multi-touch display on the iPad and the iPhone and things like that. So we've had this mouse with us for a really long time. There have been a lot of different really scary looking prototypes, being able to walk around and actually type That's been a really big deal, but only a really big deal for maybe 50 or 100 people total. This is Doug Engelbart's second prototype. He's about 90 years now, and this is me trying to use this, basically a binary keyboard device where you can input by typing in binary. It's pretty easy to learn. It's just hard to put a conductive piece of material like on your pants leg and walk around while tapping your leg. It just looks weird and acts weird and isn't very mobile. This is another example of what that looks like. Having to wear a glove is also kind of awkward. Here's another person's prototype. But this is actually the thing that Steve Mann, Thad Stern, and all of those wearable computing people use. This is called the Twiddler. It's actually the Twiddler 2. It got remade. It's now up for sale by this Canadian company. And it allows you to play keys on a keyboard as if you were playing a guitar by different chords. So you can press A and B and C and D, or you can press like 3 buttons at once to create a special character or an equation or a paragraph of text or some frequently used word. So Steve Mann would run these classes at the University of Toronto, and he would require everyone in the class to make their own wearable heads-up display, their own wearable computer pack, and write in class using this Twiddler device. And Thad Stern wrote a paper where he showed that people could learn it really quickly and go from 40 to 60 words a minute average while they were walking around. And there are still people out there today that still use this Twiddler device, and they input everything through it. It's a fantastic device. So here's how it's used, some pictures. And it's just one-handed. So you don't have to type with both hands. You can type with one hand, do something with another hand if you want. It's just a very elegant device. You also can tell what you're typing on because you can have that muscle memory. Mm-hmm. So here's an example from, there's a typing program that you can use for kids to learn this device. So as you can see, this is actually Thad Stern. Thad Stern is one of the students at MIT. This is his group of cyborgs, and they look completely different. As you can see on the very far right, that's Thad Stern, and the Cambridge constituent of this wearable computing group was very different. They all wore these kind of leather jackets, and the Thad Stern group wore like longer jackets, and they were a little bit more stylish. They used different heads-up displays as well. Here's some more pictures. There's Steve Mann on the left, Thad Stern second from left. There's this guy named Sandy Pentland from MIT. He's hanging out with a board group at MIT. And they've all got their little twiddlers in their hands that you can actually see. This is Thad Stern teaching one of his students about how to use the Twiddler device. And now Thad Stern is one of the key researchers on the Google Glass project. And that's one of the reasons why I'm very interested in the Google Glass project, because there is history involved for the last 30 years of research has actually gone into it, instead of them just deciding they're going to make a successful product without really doing any of the research in the past. So to compare and contrast a few ounces versus 80 pounds. So I'm going to switch over and talk about non-visual wearable computing now, because we've talked a lot about visual computing. It's augmenting your vision. This is something called a haptic compass belt. It's a belt that you wear around your waist and has different piezoelectric motors in it. And at any given moment, it will buzz you in the direction of north. One of the researchers in Germany who created this ended up wearing it for 6 weeks straight. And it ended up being quite incredible because he ended up actually having dreams about this thing, where he would be riding his bike in a dream, and he would always know which direction was north. He would be able to he suddenly had this like sixth sense about him, about the location around him. And the sixth sense was fascinating because he always knew which way was home, he always knew which way is work, and things like that. And so this was this incredible device for him, because if you think about it, if you add location-based directions in, you don't have to look at a map in order to determine where you need to go. You could get buzzed once, a little bit before you need to turn, and then buzzed twice when you need to actually turn right or left. You can use it by taking that visual, that whole visual interaction and kind of compressing it into a different sense, which allows you to free up your vision again. This is the other part of the haptic compass belt. It's kind of ugly. This is an early prototype. You can actually buy a kit for this online at this point. This is Mika Satomi's massage vest. It's actually a video game controller where in order to play the game. This is an example. People are pressing the buttons on somebody's back, which actually gives them a massage, but in reality, they're using those buttons to play a game on the screen. And the idea is that you have all this excess kinetic energy when you're playing a game, and it's going nowhere, and people don't like giving massages, but they like getting massages. So why not pair both of those together to make a massage vest? This is an example of how far software has come, and I mean as in software like WEAR, the whole idea of stitching technology into clothing, which is what Steve Mann was very interested in. So this is actually from a free book called Open Software from Sweden, and it teaches you how to put an LED in your clothing so that, say, when you press a button, it will connect to circuit and your jacket will light up. It's all washable, so you can actually just wash it. And so this is just something where you take something that normally isn't very high tech and you put high tech components in it, and you get this whole opportunity space that hasn't been there before.
Yeah.
So in terms of different inputs, the idea of EEG as an input is a curious thing for me. The only issue is that you have to be very still and very focused, and today's generation at least has not learned how to do that. So my joke for this is that one day everybody will have kids who will be very focused and very good at using EEG, and their parents will be part of the generation that's very fragmented. And the kids will say, "Mom, Dad, come play a game," and the parents will not be able to actually focus on the game because they never got trained on EEG when they were younger. So I'm going to talk about the future a bit now, because I've gone through the past and I've tried to kind of paint a picture of all these things that people have done very early before it was really taken up by the general public. So I'd like to talk about kind of what we're doing at Geoloqi and the whole point of the project. I mean, initially it was this thing where I watched at Xerox PARC. They're known for creating the printer. I watched at all these different other places, people creating things that we still don't have access to. We have access to the printer, but we don't have access to a location-based system, and that's really upsetting. So I wanted to create this thing called the Ambient Application, and the idea behind it is that it runs in the background and does something intelligently for you. So data is just pushed to you, and you, as a user, are the button. I was very interested in the future of the button. If you think about the actual button, it has, the original form of the button was very physical. If you wanted to change what the button did, you'd have to actually physically rewire the button. When the button became liquid, as in on liquid touch display, you could change the software in order to change what the button did. And now we have the idea of a button in the middle of the air where you can walk into it in this invisible virtual perimeter and something will happen. And so that's the idea of this ambient application. It takes you and where you are and what you're doing as an input, and then gives you information based on where you are. So the idea is that you as a human should be heightened to do what you need to do and what you're very good at, which is curation and intelligence and creativity, and a robot should be behind the scenes doing some of the work and then giving you the most relevant information so that you can actually make use of it. The biggest issue is that for years people have been trying to make computers very, and whenever they do that, they end up making humans very computer-like and very robotic. And especially when you have all these different remote controls and systems that think they know what you want, it doesn't make any sense. And I think the best person that does that, the best company that does that is Google. They figure out, using all these little robots online, what you actually want and give you not one result, but a whole swath of results that you can then choose from as the intelligent human on the other side.
Yeah.
So these are different types of user inputs. You've got location, time of day, current speed. You can also have like who the person's with, what location they've been to in the past, the demographic of the user, the user's friends. And in doing so, you kind of create your phone into being a remote control for reality. And this is all part of what Mark Weiser of Xerox PARC came up with in the 70s. He came up with this term called calm technology, which is technology that gets out of the way and lets you live your life. And it's all about this invisible interface and this very relaxing technology that just helps you instead of gets in your way. So the idea is to make the interface disappear. In doing so, your actions are reduced and you having to ask a lot of questions of the interface are eliminated. I'll give you some examples. So this is one example of an invisible interface. The person in orange walks in to an invisible geofence, and then a note is in that geofence and gets delivered to them. So this is actually a map of, this is my view of Portland on a map, and all these are invisible buttons. And whenever I go into any of these areas, it actually says, you know, Amber Case is at the airport, or, you know, Amber Case is in, you know, North Portland or Northeast Portland or Southeast Portland or downtown somewhere, or, you know, over in any of these other areas. And so I can get a notification when I enter a place or exit a place, or if I'm at a place for too long, say I'm in traffic for 10 minutes, you know, that can be recorded into a system, and then when I get home, my house can actually say, hey, you were in traffic for a long time, and start playing nice music. So if you have the, you know, the example of that, it's, I have a geofence drawn around my house, and it's connected to my lights, and when I come home, the lights automatically turn on, and when I leave, the lights automatically turn on. And it just works because the device is telling the house that I'm home, you know, and I'm carrying around the device. Another example is, you know, proximal notification. If you've ever waited for somebody to show up, and maybe they're 15 minutes late or something like that, wouldn't it be nice if you just knew when they were about a half a mile away, and then you could just deal with what you were doing and be done with it, and, you know, actually wrap up and be there, versus getting a bunch of text messages from them, which is always the issue. You know, when they're in traffic, they can't send a text message. When they're biking, they absolutely can't. And so having the device actually just tell you when they're very near is much more efficient. So we created a system that allowed you to do that. And then the other thing that we ended up building is, you know, if you have all this information in, you know, going into your device, you can actually get very interesting information back. So there was this map that we built, which is just called caseorganic.com/geonodes, where anybody can leave me a location-based message anywhere in the world. And when I get to that place in the future, it will automatically send me that message. So people started sending me these messages on bridges and at street stops, all over the place. I'd walk in a park and I'd suddenly get a notification, hey, there's berries over there, go get them. And I'd go and pick a bunch of berries that I never knew existed. I would get all this information about the history of the bridges around me. It was really fantastic. And so this is actually one of those map examples, aaron.pk/geonodes. And people could just leave a message on the map without having to know where I exactly was. There was actually a little Geiger counter on it that said, is this person likely or not to be in this location in the future? So people would leave me messages in places that I was more likely to be than less likely to be, but again, they didn't know exactly where I was, so it preserved my privacy. So the idea, again, your phone becomes this remote control for reality. This is the use case of, you know, the home automation use case. Draw a geofence around a house. When your device gets there, turn on the lights. When you leave, turn off the lights. We also, then after a while, we started building this into a platform because people said, well, I want to use this too. And so we made this little side project while we still had full-time jobs. And we said, okay, you can now build on top of this platform, and you can add external data sets in. And the biggest issue that we found is that if you take in ambient location all the time, you have an issue with battery drain. So we made a series of intelligent algorithms to take somebody's location in without severely affecting their battery life. And the big issue with location is that you've got this kind of social contract going on. In order to take someone's location, you need to give them something pretty fantastic in return, or it's a privacy violation and it's totally not worth them giving up their location. So in this case, we took the Dark Sky API and we made this hyperlocal weather alerts. And it will actually tell you 10 minutes before it's going to rain that it's going to rain in 10 minutes, and it's right on time. And so we use this because both of us bike, and when we bike home from work or decide when we want to leave, we can just look at our phones or wait for the notification. It's going to rain in 10 minutes, and then we'll get on our bikes and ride home right before the rain starts. So this is a kind of system where you're using your location for something very personal, planning for your future self, basically. This is another example where we took all of the geocoded Wikipedia articles, all on Wikipedia, and we took them and associated them with the Geoloqi platform. And now anybody anywhere in the world can subscribe to the layer. It's the GeoNotes app on the iTunes and Android store. You can go into the layers section and actually click on the Wikipedia layer, and all around the world you can get notifications of interesting Wikipedia articles around you about the buildings or strange pieces of reality around you. For instance, I found the world's smallest park by accidentally, I just walked across the street and I got this notification, world's smallest park. It's, it's about the size of, like a serving platter. That's tiny. In the middle of Portland, Oregon. It's something I would have never seen before. And I think the big issue is that data is all stuck on the web and it's not very much associated with actual place. And that makes it a really big issue because you have to actually know what you're looking for and go on the web and not be in that place when you actually get that data. And this is about getting rid of that kind of schizophrenia where you're looking at places without being tied to that place. This is marrying all of the data to that location. So we opened this platform up and people started building on it. And one of the things that they built was don't eat that, which takes all the restaurant inspection scores and ends up pushing you a notification if the restaurant inspection score of the place you just walked by is too low. It says you might not want to eat at that specific place. Another one that we did is we used what we have called the dwell time algorithm, which allows you to see how long someone's been at a place and then push them a message based on how long they've been there. So this is a bus stop notification system. If you stood at a bus stop for 30 seconds to a minute, it'll automatically message you the next bus that's going to come along. And so this is an example of the next bus that's going to come at the stop. Then we needed to test our platform. And we didn't have any test phones, and I think we were still running our little side project on like $1,000 or something like that. We said, how do we get all these test phones without having to pay for them? So what we did is we made this real-life PacMan game. And we put all of these little invisible geofences out on the city streets. This is an example where we debuted it at Stanford University. And each of these different circles all over the place is a little tiny geofence with a point value in it. And you open up the map attack game, and you join a game near you, and it automatically assigns you to the red or blue team, and then you go out and you have to physically go within the area defined by that geofence. So if I wanted to get like the 50-pointer, I'd go to that area on the map that says 50 points, and if no one had gotten it yet, it would automatically turn red or blue on my map, and I would automatically get a message that said, you got 50 points, or 20 points, or 10 points. The 50-pointers were really intense. Everybody wanted to get those all the time. So people were running all over Stanford campus trying to get all these points. And what ended up happening is, the goal of this game for me was you're stuck in front of a computer often and you don't get it to explore reality. And this was the idea of now you have a reason to explore because you're trying to get these points. People have run 3-4 miles completely exhausted, but they didn't even notice when they came back. And it was just like when you're a kid, when you run all over the place and you don't really notice that you've spent all of that time interacting with reality. And it was just this really great game. And of course these two kids ran with someone's phone and they got the majority of the points, and one guy biked through and cheated. And another guy saw Larry and Sergey of Google walking by, and I said, I should get 1,000 points for this. But the most important thing that came out of this is that I made this game, I put all the points on the board before I'd ever visited Stanford. And one of the 50-pointers I put was in a construction site. I think it was up here. And there was this guy who just went around the game board for hours and hours and hours. And he finally came back. And if you use this game, every single device is subscribed to all of the players' data of all the other devices, so you can see where everybody is on a map in real time, and you can see all the points be captured in real time, which is a really hard problem to solve programmatically. So this guy showed up, there was a 50-pointer in a construction site, and he couldn't get to it. And so he handed his phone, he caught a construction worker's attention and said, hey, can you just take my phone over there for a minute and just hold it underneath this, hold it over here for a moment? And and wait for the phone to say you got 50 points. And the construction worker's like, are you kidding? This is ridiculous. Like, what are you doing? And he said, okay, I'll do it. So he takes it over and he puts it underneath, puts it, wherever the 50-pointer was. And he said, oh my gosh, I got 50 points. Yes, this is awesome. So what are you guys doing? And the guy explained to him this game and how they were running around and how they were interacting with each other. And he said, the construction worker said, in the 15 years that I've worked at Stanford University, I've never had a student or anyone ever come up to me and actually talk to me. And I had no idea what anybody was doing being stuck in their phones all day. And this is the first time somebody's talked to me, so thank you. And they started talking all about like the future of technology and how people were distracted a lot by their phones. So this was a really interesting game to play. And it finally got all of us out and healthy again, instead of sitting in front of computers. So the other thing is, if you use location, you can also network for your future self. And there's a great startup called Doppler, D-O-P-P-L-R, and it allowed you to forward all of your trip notifications to an email address. And it would automatically tell you if people who you knew were going to be in the same place at the same time as you. So if you were traveling to Berlin, you'd forward it to trips@doppler.com, and you would get a notification that, hey, 3 of your friends are going to be in Berlin at the same time. But that is shut down, so I wish somebody would make a new service based on that. So this is my co-founder Aaron Parecki's map of Portland, Oregon. There's no actual map underneath this. This is really about 2.5 million GPS points taken at 5-second intervals that are built up over time to make this map. And it's about, I think, 2 or 3 years worth of data. This is color-coded by speed, so as you can see, the red is all the different highways that he traveled on, and then over here, that dark blue is actually him driving around downtown trying to find parking. So you can actually see like his whole behaviors and where he lives in Portland, Oregon, based on this map. But again, there's all these different things that this can get rid of, right? So if you automatically have those location notifications, there might be more social punctuation or less because you're just getting the information you need. One of the first things I did with GeoNotes was to put information down at the airport. So when I got to the airport, it would automatically tell me which bus to take in order to get into the city. And then right before my bus stop, when I needed to get off, I would make another GeoNote that said, get off at this stop. So instead of looking at my phone and digging up the address that I needed to go to when I got to the airport, I got the notification, hopped on the bus, looked at the window on the bus instead of watching the blue dot, got the notification that I needed to get off the bus, got off the bus, and then when I got off the bus and started walking, it told me which direction to go and the address and phone number of the person I was staying with. All of that did not cause me to actually look at a notepad with all the information in it. And I thought that was a really smooth way of experiencing reality. This is an actual internal system that actually says how many times somebody's been in a particular place. So you can see the most popular places you've been to. You can have these kind of different unique footprints of your city, and basically who are you versus somebody else. We'd like to kind of make that public so you could publish your own map of where you usually are. Another example is if you wanted to send somebody, say I wanted to send my boss a message, if I wasn't at the geofence that I defined as work by 9 a.m., I could do that. So if I'm not at work by 9 a.m., automatically send my boss a message. So there's all these kind of little triggers that you can set up for reality. So this is an example of just the layers functionality where you can subscribe to any of these layers of data, and anybody can put their own geocoded data in. And then the GeoNotes where you can kind of leave these messages for your future self. So this is an example of me leaving a message at the store, and then when I get to the store, I get all the information. But there's a big issue of battery drain. So we wanted to actually solve all of those, that real big core problem. So we started making these algorithms to reduce battery drain. So the whole point behind all of this is that over time, if you look at the future of the interface, you look at the future of technology, it's getting smaller and smaller, more and more powerful, larger on the inside than on the outside, and the interfaces are getting smoother and less full of friction. And so as Mark Weiser said at Park Research in 1970, the best interface is really one that's invisible, and it gets out of your way and lets you live your life. And so hopefully we'll be enabling things and systems and features that are no longer like this with 80 pounds of equipment, but like this instead. This is actually a few people who were playing the map attack game who had just gotten 50 points. So there you go. Thank you so much for listening.
Amber, that was wonderful. Thank you so much for sharing that with people. If you want to connect with Amber, you can find her online. The slides, she's got a lot of great slides over at her SlideShare, which she brought up. And then if you just unclick screen share, you actually return in that other window. And then people actually can see what you look like. And that's you, that's so exciting. So, yeah, amazing stuff. And thank you so much for spending so much time on that. it's so much more amazing than I think anyone could ever possibly have imagined. You know, gosh, we could spend the rest of the 24-hour conference just talking to Amber Case, but you're not quite, and I'm not quite cyborg enough yet. So maybe next year or the year after. But again, the work you're doing is incredibly important. It means a lot to me personally to know that there are people worried about us connecting and getting out of our devices and being able to interact. And you're an amazing, amazing human.
Well, thank you so much.
Okay. Amber, thank you. And guys, we'll be right up with the next broadcast in just a second.